actually be a classical phenomenon. Like it's something like space-time. You have the fabric of space-time, and the curvatures in it is all the cause of gravity, as Einstein told us. So all the other theories of quantum gravity have considered that space-time at its most fundamental level is actually quantum. It's not classical, as Einstein supposed. But this scientist who thought that space-time is actually classical and it's not quantum, and all these fluctuations that are occurring in space-time, they can often lead to changes in mass of objects. So the way you have quantum fluctuations, so there is continuous energy that is being created and being destroyed. You also have mass fluctuations that way. And this is a theory of quantum gravity that can actually be proved. And there have been attempts on this. So,
Yeah, that is true. I mean, the thing is, this is what Einstein was, that was the dream of Einstein.
right, sir.
He wanted to, he wanted to make sure that there is only one single equation that
Yes.
actually defines the entire universe,
The
right?
theory of everything.
And that was the dream of Einstein. Even Einstein didn't really acknowledge quantum theory, right?
Yes, sir.
He never believed that. He said that God doesn't play dice with us, right? So he said that there is something, and if there is a theory, it should have predictability. The quantum theory has a lot of unpredictability.
Yes, sir.
The assumptions and everything that it makes, it didn't actually convince Albert Einstein in a lot of sense. But still, you know, the thing is, Albert Einstein still was someone who, thought that okay, somehow they can unify gravity and quantum
Yes, sir.
mechanics. I would not say that Albert Einstein, but I would say that he was someone that he didn't really agree with quantum theory,
Yeah.
but he was the one who actually, what do you say that? You can say that he was the one who kind of didn't win the battle. This is the last battle.
Yeah.
The people who, because quantum theory basically works.
Yeah, it works.
So a lot of things that are today as working as an instrument actually it is
Yeah, like
on the
mobile
basis of
phones.
semiconductors and everything based on quantum mechanics and all. So even there are a lot of assumptions and you will feel like quantum mechanics is very weird, but it works. So this is one of the dream of scientists that they would like to unify quantum mechanics and gravity. And that's why this field called quantum gravity.
Quantum gravity.
So do you have any dream of working at NASA or
No, sir, I actually want to work as a research professor.
okay, research is that's good also. So what would be your area if you want to work as a research professor?
So, quantum gravity only.
Quantum gravity.
Like, this is basically the area that inspired me to set my goal as physics, as a physicist.
Yeah.
Like, I remember I started studying physics by reading Stephen Hawking's A Brief History of Time.
Yeah.
So, when I read that book and I read about all this quantum mechanics and relativity, then I thought about how exciting this field really is. What all the weird phenomena that is happening on the very big scale or the very small scale.
I mean, my thinking is a bit different. As a scientist, I am more like applied person. So I would like to see the world moving in front of me, and I would like to see the change what I see in the society today. For example, if I want to, if you want to, make a rocket, we want to see it, working in next 5 or 10 years. So I am more like applied physicist, or you can
Yes.
say engineering physicist who like to see things happening. Not, I'm not much interested in theory and all. I'm more like experimentalist. I would like to do experiments, observe something in the lab. Based on the observation, I make conclusions.
Yeah. They basically go hand in hand. Like you need theories for basically testing the
Definitely,
things,
definitely.
and you
For
need
anything you need theory.
observations for
For
theories.
anything you need theory. Theory is something that actually predicts our world, right?
Yes, sir.
At the same time, people would like to test your theory, whether it tests the time or not.
Right.
So, if you can make a theory and it doesn't work in the experiment, then people say that okay, your theory is not good, or you need to adapt your theory,
Right.
right? So those are the things. So more like a fundamental physicist I'm more like applied physicist. I would like to do experiments and then develop new technologies for the society. Did you read about my work on world fastest
Yes,
basically
I
moving
definitely
project?
did.
What did you understand from that?
So what basically I understood was things that this can definitely give rise to lots of confusions, like the way your research is about such a camera that is actually so fast and it can record so many billions of frames per second. So it definitely can show you nanoparticles and the creations and annihilations of these nanoparticles. In fact, it can even record a footage of light you see. The thing is, first things that I found, this will definitely give rise to confusion in lots of, you see, layman people who are not very familiar with physics, that it is actually faster than light. So that is the first thing I thought. And what I believe is that again, information cannot propagate faster than light. So you are actually recording a footage of light if you are doing that, then you are not actually getting information faster than light. Information still travels at speed of light. It is just that it's something like you have a particle moving from here, and what you do is just in case if it moves at speed of light and you are somehow able to cast a shadow of the particle at the back screen, and if the shadow is supposedly has a bigger size than the particle itself, according to various arrangements of light substance, you will find that the shadow travels faster than the speed of light, but information doesn't reach faster than light. So that is the first thing I thought. Now the second thing, that since you have done it to observe the nanoparticles that are being created, like whenever a rocket is sent into space, so all the nanoparticles.